So let's talk about something called hypothesis testing, which comes up again and again in statistics and any sort of research and sort of just all of science in general. A hypothesis in science is a statement about how the world works or how the world is. That is a hypothesis. What we do is we collect data in favor of a hypothesis. Now, the problem is we can't possibly know exactly how the universe operates, no matter how much data we collect, no matter how sensitive our instruments are, no matter what mathematical models we come up with. We don't really know what the internal structure of a proton really looks like and how things are operating at some tiny level. We just never know everything. But what we can do is we can collect data that backs up the hypothesis. If we have data from a lot of different sources that all makes it look like that hypothesis is true, we can feel fairly confident in that hypothesis. But even more importantly, we can find data that makes a hypothesis seem very unlikely. If you find data that just says, wait a minute, the hypothesis doesn't work anymore, then you move on and find a new hypothesis. Let's look at kind of a silly example. So the moon is made of cheese. Now this is a hypothesis. It's a concrete statement about the world. It's not very specific. It doesn't tell you whether we're talking about a nice triple cream brie or a cheddar, maybe a nice Parmesan. But it is a statement about the world, and it is testable. That is, we can find evidence that says, yes, the moon is made of cheese, or we can find evidence that says, no, the moon is not made of cheese. A hypothesis that we can't test is outside the realm of science. And we're not just talking about God and religion there, we're talking about other things like there's a multiverse theory of reality that says there are infinitely many Earths and realities and views. That's not really something we can test, at least not right now, maybe down the road, depending on what science comes up with, but not right now. We can gather data about whether the moon is made of cheese. We can look at light emission spectra, which if you take any sort of like physics class, every material emits certain frequencies of light, and by looking at what frequencies are emitted, we can tell what the material is. Gravity. The moon has a specific density. So if it were made of cheese, it would have a certain mass given its size, and we could see, does that fit the orbits we observe with the moon going around the Earth and its pull on the sun, for instance. We could also just lick it. If it tastes like dirty rocks, it's probably not made of cheese. Maybe some cheese tastes of dirty rocks, but most do not. So we collect our data, and we say whether the evidence backs up the hypothesis or not. And spoiler alert, the moon is not made of cheese, it's made of rocks. Sorry if that ruined anything for you. So to get a little more technical here, we often do hypothesis testing with two different hypotheses. We have a null hypothesis, which we call H0. We put a little subscript there. That is our default belief about the world. We compare that to the alternate hypothesis. This is an alternate explanation for how the world works. So what we do is we collect data. And if the data is very, very strong in favor of the alternate hypothesis, we would reject the null hypothesis and say it looks like the alternate is more likely. Only if the data is very strong, though, because remember, this was our default belief. We're not going to change our minds for nothing. So we conclude the null hypothesis is more likely unless the data is really convincing us in favor of the other one. So let's look at the center of the universe. The null hypothesis, the Earth is the center of the universe. The alternate hypothesis, the Earth revolves around the sun. Now, this is the null hypothesis because people believed it for a very long time. It was the foundation of a lot of, I don't know if theological is the right word, but there were a lot of scholars and thinkers and monarchs or whatever who put a lot of stock in this. So you can't just tell them they're wrong unless you have a lot of evidence. I think it was, I don't remember, Kepler or someone who was convicted of heresy for saying that the Earth revolves around the sun. It just really went against the model of the Earth being the center of the universe. Of course, nowadays we know it happens to be true. The Earth goes around the sun goes around, I don't know, the galaxy, and the galaxy goes around, so I don't know. It gets all complicated. But the Earth is definitely not the center of the universe. We're fairly certain of that at this point. So a more serious example, climate change. Now, the climate on Earth is driven by natural cycles that have existed for hundreds of thousands of years. That is absolutely true. It's a null hypothesis because it's our default belief. And there's lots of evidence on natural cycles. We've seen ice ages. We have sunspots affect the weather and the climate on Earth. There's El Nino patterns. I don't know much about those, but they exist. The CO2 levels in the atmosphere have gone up and down over time. So these natural cycles are just part of Earth and something we as humans have to deal with. The alternate hypothesis is that in addition to all of these, the climate on Earth is being dramatically altered due to humankind's release of greenhouse gases. Now, whoa there, that seems nuts. It's extremely inconvenient because if it's true, there'd have to be immense consequences to our entire civilization. So we need a lot of data. We have to be really, really sure that this is true before we reject this. And the problem with rejecting the null hypothesis is randomness is everywhere. And it can be difficult to separate random effects from actual patterns. If you're testing a new asthma drug and some people get better and some people don't, how do you really know it's effective? That is module 3 in this course, I believe. Again, is the Earth warming due to fossil fuels, or would it be warming anyway? Maybe without them, we'd still see the same natural cycles that are just seeing as part of our warming right now. Another one that's big in the US, does fracking cause earthquakes, or would there be earthquakes anyway? The science is getting pretty conclusive on this one that fracking is bad, but it's made natural gas really cheap, so trade-offs, I guess. And the last thing, let's look at this again. This is our average minimum temperature by month, the average minimum like for January, March, April, May, June, July, etc. for January 2007 through December 2018. When we plot this, we do see a gradual upward trend, but these dots are all up and down. Sometimes we have a really cold month. Sometimes the summer, the average minimum is lower than others. So how do we really separate the randomness, the up and down, not just of the seasons, but of the months within the seasons, from the actual warming pattern? And that's taken the climate scientists several decades to really be absolutely certain. At this point, there's kind of overwhelming evidence, but it's extremely inconvenient. So, trade-offs of believing it. But that's sort of the difficulty, is separating the randomness from the overall patterns. And that's something you are going to look for in your data. And we're going to keep coming back to the hypothesis testing for the rest of the term.